Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is divide array into arrays with max difference. Now the problem category is of medium level, but I would say this is actually a very easy question to solve, and after watching this video, after understanding the problem and the solution approach and the thought process behind the solution, this problem is going to be very easy for you. The given input in the problem is an integer array, and let us call that integer array as nums. The size of the array, that is the size of the given integer array nums, is n. That is, the given integer array nums has a total of n elements, and the question says that the value n, that is the number of elements in the given array nums, is divisible by 3, or we can say n mod 3 is equal to 0. So basically n is divisible by 3, so the value of n can be 3, 6, 9, 12, and so on. We are also given another input, which is a positive integer, and let us call this positive integer as k. So we are given a total of two inputs, an integer array nums and another positive integer k. The output which we need to give in the problem is a two-dimensional array. Now the given integer array as an input nums is a one-dimensional array. We need to find a two-dimensional array, and we need to return this two-dimensional array as the output. Now if you read the question name again, it is divide the array, divide your integer array nums into arrays, that is multiple arrays with max difference. Now let us try to understand how can we go from the input to the output. Let us try to understand the task. And the task says that the first point is we need to divide our array nums. This nums is given in the input. So we need to divide the array nums into n divided by 3 number of arrays. And every array will be of size 3. That is, let us try to understand this point again. We need to divide our array nums into n divided by 3 number of arrays. Every divided array will be of size 3. For example, if the number of elements in your array is 12, and you need to divide this array nums, right, which has 12 elements, and you need to divide it into total 12 divided by 3 arrays, which is equal to 4. So you need to divide this nums array, which has 12 elements, into 4 different arrays, and each array is going to have 3 elements. We have total 12 elements. The first array is going to have 3 elements, the second array is going to have 3 elements, the third array is going to have 3 elements, and the fourth array is going to have 3 elements. That is, a total of 12 elements is divided into 4 arrays, each array is having 3 number of elements. Now the second point says that in each of the array, in each of the divided array, the difference between any two elements of the array cannot be more than k. Now again, this is another very important point which you need to understand. When you divide your array into multiple arrays, and those multiple arrays are going to have a size of 3, that is, it is going to have 3 elements, and let us say the array which you create has 3 elements, a comma b comma c. This is one array which you got after dividing your array. So the second point says that in each of the divided array, the difference between any two element cannot be more than k. That is, the difference between a and b, the difference between b and c, and the difference between c and a cannot be more than k. It means it can be up to k. It can be up to k. If the value of k, let's say the value of k is 2, and you have 3 elements, a comma b comma c, in your divided array, then the difference between a and b cannot be more than 2. It can be 0, it can be 1, it can be 2, but it cannot be more than k. It cannot be more than 2. The difference between a and b cannot be more than 2. The difference between b and c cannot be more than 2. And the difference between c and a cannot be more than 2. So we basically need to divide our array nums, which has a size of n, into n by 3 number of arrays. Each array is going to have 3 elements. And you basically need to return a two-dimensional array as an output, in which each array is created using the above process. That is, you just divide your array nums into multiple arrays and you return it as a two-dimensional array. Now, there is one more point, that if such two-dimensional array, such 2D array cannot be created, then we need to return empty. Or we can say we need to return an empty array. This is an empty array. Now let us try to understand the same thing using two different examples. In the example number 1, the given array nums is 1, 3, 4, 8, 7, 9, 3, 5, 1, and the value of k is 2. The output in this case is a two-dimensional array in which each element is an array of size 3. And this is basically created by dividing this array into 3 different array of size 3. Why have we divided this particular array into 3 different array? Because the total number of elements in the given nums is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements are there. You divide this 9 by 3 because 9 is right now the value of n. And we need to divide our array nums into n by 3 number of arrays. 9 divided by 3 is 3. So we divide our array nums into 3 different arrays, 1, 2, and 3. Each of the array is going to have 3 elements. And there is one more point. Any two element in this array will not have a difference more than k, that is more than 2. Let us see how. In the first array, the different pairs which you can have is 1 and 1, right? They have a difference of 0. There is another pair which is 1 and 3. They have a difference of 2, which is fine. And there is another pair which is 1 and 3, and they have a difference of 2, which is fine again. In the second array, the pairs are 3 and 4. 3 and 4 has a difference of 1, it is fine. 4 and 5 has a difference of 1, it is fine. And we have another pair which is 3 and 5, it has a difference of 2, which is fine. And similarly, the third array, 7, 8 has a difference of 1, 8 and 9 has a difference of 1, and 7 and 9 has a difference of 2. So we cannot find any two element in these arrays which has a difference more than 2 or more than k, I would say. So this is the output which we have. Now the thing is, if you have multiple answers, that is you can create some other two-dimensional array which satisfies all the condition, you can return that answer. If you have multiple answers, you can return any answer. And if you don't have any answer, that is you cannot divide your array into n by 3 number of arrays such that the difference in each of the array which is created, the difference between any two elements is more than k. In that case, and if you cannot create such array, then you need to return an empty array, and that's what we have in the example number 2. In the example number 2, the given array nums is 2, 4, 2, 2, 5, 2. The value of k is again 2. It means none of any two element can have a difference more than 2. The output here is empty. That's because we cannot divide our array nums into such arrays. So we basically have 1, 2, 3, 4, 5, 6, 6 number of elements. We need to divide it by 3. This is equal to 2. So we need to create a total of 2 number of arrays from this given array nums, and those two arrays is going to have 3 elements. Now we can divide this array into two such arrays. We can say the first array is 2, 4, 2 and the second array is 2, 5, 2. The first array is fine. We cannot find any two element in this array such that the difference is more than k. But in this array, we have a pair 2, 5. These two elements, they have a difference of 3, which is more than k. So this particular is not valid. So you might say that, okay, I'm not going to divide our arrays in these two parts. I would divide it in some other triplets. That is an array of 3 numbers. I would divide my array nums into some other triplet. You can try any combination. For this input, you cannot divide your array into two arrays such that each array is going to have 3 elements, and the difference between any two element of those arrays is less than equal to k. And let me actually try to show you that this is not possible for this input. Let us say you try to create an array and you try to fill this element 5. If you fill this element 5 here, you have two more elements which you need to fill in this array, because we need to create our sub arrays, or I would say the divided arrays of 3 elements. So if 5 is here, then you cannot put 2 in this particular array, because if you will put 2, 2 and 5 will have a difference of 3, which is more than k. So now again what you will do, you will say, okay, I will have an array which has 5 and which has 4. This is the 5, this is the 4, right? They have a difference of 1, which is fine. But now you have to choose one more element, and the options are 2, 2, 2 and 2. And you cannot put 2 here because 2 and 5 is going to have a difference more than k. And that is why we cannot divide our array nums into n by 3 arrays, because one of the condition is failing. Now the thing is, guys, we need to understand the solution approach for this problem. And to solve this problem, we need to follow an algorithm called as greedy algorithm. Now you might have heard about greedy. Greedy algorithm is about making a local optimal choice at each step. That is, we try to make a choice, or we try to take the solution which is available as of now. We don't wait for the solution. We just try to choose the most optimal choice which is available locally. That is, in greedy algorithm, we just choose the local solution, and we just hope that this will lead us to a global correct solution. That is, we don't wait to process the other inputs or the other data we have. We just try to process the data which we have as of now, and we see that is this data correct, or is this data the correct choice. And if it is the correct choice, we don't wait for more data, we make the choice, and we think that this is going to lead a global correct solution. For example, if this is our input, let us say this is our input, then what we do, we say that, okay, we need to create a triplet, right? We need to divide our array nums into multiple arrays, and each array is going to have 3 elements. So let me try to choose the first 3 elements which are available. This is the first element, this is the second element, and this is the third element. So we will say, okay, 1, 3 and 4 can be a particular triplet or can be an array. But the problem is they are not compatible together, because the difference between 1 and 3 is fine, which is 2, but the difference between 1 and 4 is not fine. So then I would say, okay, I can say 1 and 3 can stay together, or I can say 3 and 4 can stay together, but 1 and 4 cannot stay together in one divided array. But this is what greedy algorithm do. It tries to choose the most optimal choice which is available as of now, which is available locally, and then try to hope that this is going to create a global correct solution. But as of now, this greedy algorithm is not working, right? So why I am saying that greedy algorithm will still work. Now I would want you guys to question yourself that what is the goal of this problem. The goal of the problem is to keep the difference between elements within an array of or a group as low as possible, or I would say less than or equal to k. That is, try to understand this statement again. Our goal is to keep the difference between the elements within an array or group as low as possible, less than or equal to k. Let me try to tell you this with example number 1. The groups which you are creating, you want that these groups of 3 elements, none of the 2 elements in any group are going to have a difference of more than k, right? So you want that the difference between any 2 element in my array or in my group should be less than or equal to k. So if the value of k is 2, I want the difference to be 0, 1 or 2, as low as possible, right? As less as possible. And that's what this problem is. Our goal is to keep the difference between elements within an array or group as low as possible, or I would say less than or equal to k. Now the thing is, if you want that a particular group should have the difference as low as possible, it means that the numbers will be very close to each other, right? If you will see the output of the problem number 1 or the example number 1, in the output the elements are 1, 1, 3. They are very close to each other. 3, 4 and 5 are very close, and 7, 8 and 9 are very close, right? As compared to the other groups. 8 is very close to 9 and 7. 8 is not close to 1 and 3, right? As compared to 7 and 9, right? So that's what we need to do. So basically this point is suggesting us to group similar numbers together. And this is actually telling me that you can apply sorting here. You can sort your data so that naturally the numbers which are close to each other will be close to each other in the array as well, right? Right now you can see the numbers like 1, 1 and 3, they are very far from each other, and it is very hard to understand or to find that they actually belong to one group. But if the numbers are sorted, the 1, 1 and 3 are going to be very close to each other. And why I am thinking of sorting? That's because I know that the differences of the element in the similar group or the same group is going to be as low as possible. And this is suggesting me that we can use sorting. We can sort our data, and this is going to help us to create the groups. Because right now, if we try to create the first 3 element group, we cannot do it. So now I will be confused that, okay, should I take 3 and 4 together, or should I take 1 and 3 together? Because 1 and 3 together works, 3 and 4 together works, but 1, 3 and 4 together does not work because of 1 and 4 being in the same group. But 3 works with 1 and 4 both, right? The difference between 3 and 1 is fine, it is 2, which is within the limit. The difference between 3 and 4 is fine, which is 1, which is within the limit. So I know that I can see in the input the numbers are all over the places. Similar numbers or the numbers with less differences are not together, and that is what we need to do. So we can just sort the data, and after you will sort this particular input, this is going to look something like this: 1, 1, 3, 3, 4, 5, 7, 8, 9. Now this is your data, and this is the same data you have in the nums, but this data is sorted. And we know that in the problem says that we just need to return the two-dimensional array which is possible, and if there are multiple answers which are possible, we just need to return one answer. We don't need to return all the answers, or we don't need to count all the answers. So if we do not need any kind of counting, we don't need dynamic programming here. We need is greedy algorithm, and that's what we are doing. We are just sorting the data, and after sorting the data, creating the groups, or I would say dividing the arrays, is going to be very easy. Now you just need to select the next 3 available elements, and that is what greedy algorithm is all about. Greedy is about making the local optimal choice, and that's what we are going to do here. And this local optimal choice is going to become the global solution for this problem. You can say the first 3 elements 1, 1, 3. Forget about the other elements. Just focus on the first 3 elements 1, 1 and 3. So I know that this element is going to be the lowest element, this element is going to be the mid element, and this is going to be the largest or the number with the highest value, right? Now what I can do is I can say what is the difference between the first and the third element, because the difference between the first and the third element is going to be the highest, right? That's the highest difference which we can have in these 3 numbers, the difference between the first element and the third element, right? Because if the array element are 1, 1, 3 and they are sorted, so this is the lowest, this is the largest. The difference between the lowest and largest is always the max, right? If the numbers are 1, 1 and 3, take the difference between the first and the third element, I would say 3 minus 1, which is equal to 2. Now if this value is within the range, if this difference is within the range, then this triplet is fine. We can divide our array into these 3 elements, because the maximum difference we have in this particular data is equal to k. Other differences between the first and the second element, or the second and third element, will always be equal to or less than this value, which is equal to or less than k. So I can say 1, 1, 3 is a fine pair, or a fine triplet, I would say. The next 3 numbers are 3, 4 and 5. In 3, 4 and 5, you can see that this is the lowest, this is the largest, their difference is 2. Now if their difference is 2, then the difference between 3 and 4 and 4 and 5 is always going to be less than equal to 2. It cannot be more than 2, right? So the highest difference we have is 2, and this value is within the range. The value of k is 2. So 3, 4, 5 is also a fine triplet. We found our first triplet, the second triplet, and then we can say the last 3 elements in the array is 7, 8, 9. Then what I can say, 7, 8, 9, this is highest, this is lowest. Their difference is going to be equal to 2. 9 minus 7 is 2, which is within the range. So I would say this particular triplet is fine. And like this, I can just sort my data and check for each of the next three numbers. If they are fine, I will create an array of it and I will append it in some other array. Let us call it as my output or result array, which is going to be empty. I would just select the first three element, then the next three element, then the next three elements. I'm just going to check the condition, and if it is valid, I'm going to create an array of it and I'm going to append it in my result array. Now let us quickly understand it for the second example as well. We first need to sort our data. This is our data. After sorting, this is going to be 2, 2, 2, 2, 4, and 5. The first three elements are 2, 2, 2, right? Now the value of k is 2. It means the maximum allowed difference is 2. The highest value is 2. The lowest value is 2. The difference is 0. It means that 2, 2, 2 is a fine triplet. You can create an array of these three elements, 2, 2, and 2. The next three elements are 2, 4, and 5. Now in 2, 4, and 5, this is the lowest, this is the highest, their difference is 3. And if the difference is more than k, then we can just directly return the value as empty array instead of doing anything. That is, if we cannot create such array, then we can directly return an empty array. And I think guys, that's the complete explanation of this particular problem. Let me take you back to the code editor. Let me try to show you how the solution is going to look like in Python. So this is the complete code for this particular problem, and it is a very clean code. So we have nums.sort. Then we create a variable result, which is equal to an empty array as of now, or an empty list. Then we just run a simple loop in our array for I in the range of starting with index of 0 and going till length of nums. And this is the step, that is, after index 0, the next value of I is going to be 3, then the next value of I is going to be 6, and the next value of I is going to be 9, right? This is how loops work in Python. This is the starting index, this is the ending index. Ending index is not included in this range. And then we have the step, the number of steps we are taking. I'm choosing the value as 3 because I need to choose the next three elements every time, right? So I would say 1, which is the first element, will be equal to nums of I. 2 will be equal to nums of I plus 1, and 3 will be nums of I plus 2. These are the three elements. These are the next three elements I have in my array. And I would say if the difference between the third element and the first element is less than equal to k, then these three numbers are valid to form a group or an array. In this case, I would say result.append this as an array or a list in which the numbers are 1, 2, and 3. And if anytime I find that this condition is not true, I would directly say else return an empty array or an empty list. And if after coming out of this loop, I'm not returning back, it means that all the triplets are created, which is stored in the value or variable result or res. And then we can just directly return the value of result or res. And that is going to be the complete code for this particular problem. Sort your data, check for the condition. If it is true, append it in the result. And this is the complete code. And this is actually a very clean code to understand the solution as well. You can just submit this code and this is going to pass all the test cases. And this is actually a very efficient solution. Right now you can see the runtime is 50%, the memory used is 76%. I actually submitted the same solution few minutes back and it gave me a runtime of 94%. So it's basically a really clean code and a really efficient code, I would say. So guys, I think that's it for this video. I hope this video explains you the problem, the solution approach as well, and why are we doing sorting as well. And if it did, then make sure that you hit that like button. And if you have not subscribed to the channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.